Okay, so we're in section 12.5, the last section that's on exam number 4, exam we're going to take next week. So 12.5, logs. How do we do logarithms? Well, what a logarithm is, sounds like a really weird thing. What it is, it's the opposite of a power. Logarithms are inverse power functions. They're the opposites of powers. So, what that means about this problem, what it is we need to do this problem, let me just write it for you. They're the opposite, or really technically the inverse of powers. They're the inverse of power functions, the opposite of power functions. Now, notice how the logarithm has that 4 is kind of lowered down, you know? It's meant, it almost looks like a power thing, doesn't it? Doesn't it look like 4 to the 1,024 power? It's meant to look that way. It isn't exactly 4 to the 1,024, but it's meant to make you think about powers. That is exactly what a logarithm is. It's the inverse, or the opposite, of powers. So that's why they're making it look that way. That's why they put this number lower down. This number is called the base. Base just means bottom. Like this is a, what are those called? Those little baseboards, right? Because they're on the bottom, right? If they were up there, they wouldn't be called baseboards. So when we call this log base 4, all we mean is that's the bottom. So that's the base. Okay, so what? So it's the inverse of powers. So basically on these first questions, all they're going to have us do is translate in and out of the log language. It's going to be like me saying 1 and then uno. I'm saying the same number, different language. That's all we're going to do at first. We're going to say, all right, we're making a statement in the log language here. We're not going to solve anything. We're just going to change the language. We're going to change from the log language to the normal language. How do we do that? Well, we got to get rid of that log word. How do you get rid of that log word? Well, what's the base there? What's the lowered down number? 4. So what you do to get rid of that is you bring in a 4 lowered down on both sides. Bless you. Whatever you do on one side, you have to do the other, right? When two things are equal, we got true and the same. And what happens is these guys cancel each other out. Because powers and logs are opposites. If the bases match, they cancel. So you just cancel that out. Okay, so what does that give you? 1,024, bring this down, 4 to the 5th, done. That's all they want us to do for these first few problems. What did we do? We just translated. 4 to the 5th power, you can check your calculator, it is 1,024. And the logarithm is saying, that's what I was saying all along, in his reverse language. That's what he was saying all along. All right, so let's try. So all they're going to ask you to do is rewrite it. Basically, they're going to say, rewrite as an exponential. Exponential means powers. So rewrite it, get rid of the log word. So how do I get rid of that log word? Well, the power is the opposite. Am I making any sense when I say opposite? Let me show you one more time. What if I had x squared is 9? How would I turn that into normal x? What would I do to turn that into normal x? Yeah, I would root it, wouldn't I? And you had to do it to both sides. Why would I root it? Because rooting is the opposite of 2 power, isn't it? Well, that's exactly what I'm doing with this log thing. I'm not rooting it, but I'm doing the opposite. Is that making sense? I'm getting rid of it by doing the opposite. And what's the opposite of a logarithm? A power. So what power am I going to do? 10. Both sides, these cancel. Does that make sense? So whatever the base is, you just base power that to both sides and it gets rid of the log. Because that's what a log is. It's the opposite of a power for the same base. Just like a root is the opposite of the second power. They cancel each other out. So that gets rid of it. And then what does that give us? That brings down 100,000 is 10 to the 5th, and we're done there. That's all they want us to say, is 100,000 is 10 to the 5th. Is that good? Let's try another one. What's number 3? Log base e of 1 over e to the 9th is negative 9. Is that right? Yeah. Okay, that's kind of weird. They're really bringing out some weird stuff. That e, don't worry about it. It's just, e's a special number. It's like pi, whatever. We don't have to do anything with it. So, how am I going to get rid of that log word? What am I saying? Same thing on. So all these first 3, maybe another one, I'm not sure. They want me to rewrite as an exponential. They want me to get rid of the log word. So how do I get rid of that log word? So whatever's at the base, whether that's an e or a 10 or a 4, whatever's lower down next to the g of the log word, whatever's lower down, that's what you put on both sides, huh? Does that make sense? Whatever's here, you just put that on both sides. Whatever's here, you just put that on both sides. So same thing here. I'm going to put e and e, even though we've already got a lot of e's, it seems like. I'm going to put another e, and that'll cancel this out. Is that good? And then that'll give me 1 over e to the 9th is e to the minus 9. And we're done. That's all they want for now. We're not solving for x. We're just practicing changing in and out of the log language. There's no more log. That's what they wanted. I got rid of the log word. There's no more log word there. Is that making sense? So logs are the opposites of powers. To get rid of a log word, you just power both sides, the same as the log base. Same as the number next to g. And it'll go away, because it's the opposite of that. That's what it is. Same thing, they want you to get rid of the log word. So go ahead, get rid of the log word on this one. So what am I going to do to get rid of that log word? Yeah, 0.2, 0.2. And really, you know what? That 0 is not needed. Just 0.2. I mean, you could put it if you want to, whatever. Goes away. So then we have, I'll bring this down. I don't put the zeros in the front. It's not needed. There we go. There's the same truth said without the log word. I got rid of the log word. Logs are the inverses of powers. That's what they are. That's how they were actually created in the first place, to be the inverses of powers. Good? Is that good so far? So we're not solving anything yet. We're about to. But we're just getting used to getting rid of the log word. How do you get rid of the log word? Power both sides by the base. And it goes away. They don't want me to work any more out. Just lower. That you know, right? You know 8 squared is 64. 8 times 8 is 64. What do they want me to do? They want me to write it in log. Is that right? Yeah. Write as a log. So I'm still just translating. I'm really not solving anything. I'm just doing the 1, uno, 1, uno. Now I'm going uno back to 1. I'm just saying there's a statement that doesn't have the log word in it. They want me to put a log word in there. Well, how do I do that? Well, what's the base on the first statement? What's the base? No, the base, like this is the base of the table because it has something on it. The base is something low down that has something on it. So what's the base? Who has something on him? The 8. The 8's the base. You with me? The 8 is the base. He's the bottom that has something on him. The 8's the base. Well, that tells me what to do. I'm going to do log base 8 on both sides. You got to do the same thing to both sides as always, right? When two things are equal, treat them the same. They'll still be equal, as you know. So I'm bringing in a log because they're asking me to bring in a new log. Now, what happens on the left side? You see what happens? These just cancel. Because logs and powers are opposites, they cancel. So 2 is log base 8 of 64. Done. So the same truth that was said originally with no log word is now being said as a log. They're both saying the same thing in different languages. The second one's in the log language. Is that okay? So instead of doing the power on both sides, I did the log on both sides. So if you need to get rid of a log, you do power on both sides. If you need to bring in a log, you just do the log on both sides. We're always doing the same thing to both sides. Let's try number 5. What's 5? E to the 5 equals x. Or that was number 6, right? Yeah, e to the 5 equals x. Number 6. E to the 5 is x. Okay. Can you do log? They want you to write it as a log. Rewrite as a log. Who's the base? E. Yeah. So you're going to log base E, both sides. So I'm going to log base E this side, log base E that side. We good so far? So I did log base E on both sides. And now do you see what happens on the left side? These just cancel, and it's just 5 is log base E of x done. So remember again, the log and the power, the base of the power, cancel each other out. Because logs are the opposites of powers. That's their very nature. They're the opposites of powers. Good? Questions on that one? Try that one. Rewrite as a log. So rewrite that one as a log. So you got to put the log on both sides. What's the base? 2. 2 is the base. 2 is the low down number that has a power on it. So I'm going to go log base 2 on this side and log base 2 on that side. We good so far? Is that making sense? See how we always log both sides? Is that okay? And then what happens? Yeah, that left side, those cancel like that. And so this is just minus 3 is log base 2 1/8, and we're done. Does everybody see why do they cancel out on the left side, but they don't cancel out on the right side? Is that okay? They cancel on the left side because there's 2 of them. They match, huh? The log base and the base of the power match. That's what makes them cancel. Whereas on the right side, we don't have that. So they just stay. The log just stays. Is that good? Okay, so we're going to do log base 8 of 64. Let me, what would be the easiest way here? Yeah, let me, yeah, okay. Yeah, so what we're going to do is we're going to put an X on the right side. I'm going to go equals X. Since there's nothing on the right side, I'm just going to go equals X. That's just like giving it a name, like you would name a pet or something. Okay, you're Rover or whatever. I'm just calling that thing X. And now I want to solve for X. And that'll be my answer to this question. How can I solve that equation for X? What do I do to solve this equation for X? Yeah, because you got to get rid of that log word, huh? You with me? Is this making sense? we have to get rid of that log word. What's going to get rid of that log word is the same base, right? Logs are the opposites of powers. So do the power on both sides and the log will go away. Correct. So we do an 8 here and an 8 there, and this goes away, huh? Is that good so far? So then we have 64 is 8 to the x. And now, can you solve for x, like I was saying, kind of by observation? Like, what does x have to be? 8 to what power is 64? It's got to be, x has got to be 2, doesn't it? Does that make sense? X has got to be 2, because 8 squared is 64. 8 times 8 is 64. And we're done. We solved it. Now, I want to give you another way, which you'll probably prefer. But I did want to show you the by hand way too. Or, let me go back to the problem. Log base 8 of 64. Here's the other way, just using your calculator. On your calculator, you can just do the top log on the top and the bottom log on the bottom. Make it 2 logs like that. Hit the buttons on your calculator and you'll get the same answer. You'll get 2. Get log of 64 divided by log of 8. Try that on your calculator. You should get 2, just the same answer. Make sure you close off the parentheses when you do the first one now. You know what I mean? It's got to be log of 64, close the parentheses, divided by log of 8 equals. And you should get 2. Getting 2 like that, okay? On the calculator?
Did you get it the first time without the calculator?
Yeah, so the first time, I just did the 8 on both sides, and I canceled out. Then I just said 8 to what power 64? I just kind of looked at it, solved observation. I just said it has to be second power, 8 squared. So I just looked at it. Does that make sense? You guys able to get that in the calculator as well? So that's another way you could do it. You can make it 2 logs. So what's the rule there? Because sometimes people get confused which one goes top and bottom. The one that's higher up, 64 is higher, goes in the top. The 8 is lower down, goes in the bottom. Top and top, bottom and bottom. Hit the buttons. Get 2. You don't have to do any of that X stuff. All right. Can you do that one? You can just do it right on your calculator. Yeah. So what do you do on your calculator? The top one goes top, the bottom one goes bottom, like that. You make it 2 logs. So on your calculator, you make it 2 logs. And if you hit the button, don't you get like 0.333333 forever? You guys getting that? I think you do, don't you? 0.33333, which that's the same as the fraction 1. They want a fraction answer on this problem. That's the same as 1/3. That decimals, you've probably seen that before. 1/3 is 0.3333 forever. You able to get that in your calculator? So the top goes top and the bottom goes bottom like that? Questions I can answer on that one? Let's try number 10. 10 says log base 8 of 1. We'll try that one. Same thing. The top one goes on the top, the bottom one goes on the bottom. Log base 8 of 1. Use your calculator. The top one goes top and the bottom one goes bottom. And just 0, huh? 0 on that? Because the top is 0. 0 over anything, 0. Is this coming out okay on your calculators?
questions. Number 11, log base 9 of 81. Try that one.
Yeah, that's a 9.
Make it a little neater here. Log base 9 of 81. So again, make it 2 logs. Top goes top, bottom goes bottom. On the calculator, so the top goes top, the bottom goes bottom, and it comes out 2 again, huh? Guys able to get that? And now, if you want more like tips and stuff, what it's doing, if you're wondering what it's really doing, log is, like I said, it's the opposite of a power. So what it's really saying, if I give you this, you could probably just do the answer without even your calculator. It's saying power needed. That's how you could think of it. Instead of being a power, it asks for a power. It's the opposite. So notice it's saying what power is needed on a 9. What it's really saying is 9 to what power will be 81? What's the power needed on a 9 to become 81? Well, 2. Right, and that's the answer, huh? So if you want, there's another way of doing it. I'm just giving you several different ways. That's what a log really does. Instead of a power, it's the opposite of a power, as we've talked about. It's a power needed. It's the power needed on a 9 to become 81. It's 2. 9 squared is 81. Anyway, you just use your calculator. You don't have to do that whole power needed thing. Are we good? 12? Okay, yeah, no, 12 we're going to go for something a little different. Log base 2 of 32 is x. Okay. 12. Log base 2 of 32 is x. Okay, yeah, let's do this one now. So number 12, this is a good question. How do we do this one? What are we going to do? We want to solve for x there. Can you solve that for x?
2 on each side.
You could. Or you could just do the left side using your calculator. That makes sense? Either way. Yeah, you could get rid of the log word by 2 powering both sides. Or you could just say, forget about that. I'm just going to do this on my calculator. Right? The top goes top. The bottom goes bottom. Hit the buttons. X is 5. We're done. Did you get that? You could just do that. Is that making sense? I think it's one like this that I just put on the exam. If I'm remembering right. I think I put this one on the practice exam in preparation for the one in the real exam being very similar. Now, let me show the other way. I'll say or, because if you were thinking, what about the stuff we learned? Yeah, you could. You could totally go 2 to both sides, and that would cancel this out. That's correct. That's the other way. And then that would be what? That would be 30, whoops, scribbly there. That would be 32 is 2 to the x. And then, how are you going to solve that? 2 to what power is 32? Well, you can just try it on your calculator. Just go 2 times 2 times 2. You'd find out it takes 5 times. X is 5, same answer. Either way. Easier just doing your calculator, of course. Is that good? Is that making sense? I feel like I'm going pretty quickly through these. Is this okay? Okay, yeah. So that one we're going to have to use the properties a little bit more. So what are we going to do to solve there? We're trying to find x. How are we going to solve that for x? What are we going to do? Is there any way we could just get rid of that log word? Because that's what we like, right? That's what's bugging us, confusing us, is that log word. How could we get that log word just out of there? X. Yeah, x power, both, put an x in the base on both sides, right? Because remember, it's opposite. Logs are opposites of powers when the bases match. Yeah, good. So just do x in the base, and these cancel like that. Is everybody getting the hang of that? So there's one like this also. There's, like I said, there's 2 on the test from every section. I believe there's one like this also. So then we get to there. Is that good so far?
That gets, how do you get rid of a log word? You power both sides by the same base. Because logs are opposites of powers. What is a logarithm? The opposite of a power. I would have had no idea about that. Somebody would ask me when I was like you all in junior college taking math and science classes. Somebody said, what is a logarithm? I would have said, I have no idea. I could do them. I learned the rules. But like what it is, I have no idea. So what is it? It's the opposite of a power. Logs are opposites of powers. So that helps you know what to do. We get to here now. How do we solve for x at this point? How do we get x alone? How do you turn x squared just like into normal x? Root it, yeah. Just root both sides. Isn't it 14 on your calculator? There's our answer. Normally when we root, we do plus or minus. I don't know if you remember. But you can't have a negative on the 14 because the x was originally a base. Bases can't be negative. So it's only the regular 14. Does that make sense what we did in general though? We got rid of the log word by powering both sides to the same base. That's how you get rid of a log word every time. Try that one, log base 2. Oh, you can just do that in your calculator, huh? See, if the left side doesn't have an x, you could just do that whole thing on your calculator. You know what I mean? That whole left side, you could just, the top goes top, the bottom goes bottom, hit the buttons. Answer should be -4. You see how that's different than the last one? I'll flash back in just a second. First, is everybody getting that okay? With your calculator, the top goes top, the bottom goes. It's because we didn't have an x on the left side. So I could just straight do the left side. Whereas the last one, you see, we had an x over here. So I couldn't really do this left side on my calculator. I had an x. So I had to get rid of the log word first. See the difference? By doing the x on both sides, that got rid of this. Whereas this time, it's just all numbers. So just use your calculator. Everybody seeing that difference? If you just have numbers with the log, just use your calculator. If you have an x in the middle, you're going to have to power both sides to get rid of the log. Two different. Number 15. Can I just use my calculator on number 15, or do I need to power both sides? Is the left side just numbers? Yeah? Just use your calculator. Right? If it's just numbers on one side, just use your calculator. So the top goes top. The bottom goes bottom. The answer's 4. Good? See how if one whole side, if the logarithm just has numbers in it, then just use your calculator. But if the log has an x in it, if either this guy or that guy is an x, then you're going to have to do something harder. You're going to have to power both sides to get rid of the log word. Is everybody seeing that game plan? We remember that game plan in a week? You'll think about nothing else all week, right? Your other less important classes, we'll just go to the side. I'm just kidding around. All right. So let's try the next one, see if this is making sense. So number 16, log base 8 of x is 3. 16, log base 8 of x. Is that right? Log base 8 of x? No, x of 8. Oh, I got that wrong. Log base x of 8. Is that right? Yeah. All right. Try that one. So now, are there just numbers in the log? No. So you can't just use your calculator. There's not just numbers in the log. So you're going to have to power both sides, huh? So go ahead and power both sides to get rid of the log. Everybody seeing the two different strategies? If there's just numbers in the log, like the last two problems, then just use your calculator. But if there's x's in the log, you got to power both sides to get rid of the log word. Okay, so what am I going to, so I got to power both sides. I got to get rid of that log word because it's not just numbers, got an X in it. So what am I going to power both sides by? X, yeah, whatever the base is, huh? And it just cancels, right? Is that good? It's making good sense. And so then we have 8 is X cubed. Can you solve that one by observation?
Yes.
What to the third power? What times itself 3 times? That's what X cubed means, right? What number times itself 3 times is 8? 2. 2 times 2 is 4 times 2 is 8. 2. Solved by observation. Good? That making sense? I mean, you could cube root both sides, whatever. I think it's better just to look at it and go, it's got to be 2. 2 it is. This good? Questions I can answer? Okay. Any thoughts? Well, I'll let you write it down. What do you think about that left side?
Put the 2 on the other side of the log.
Remember what we learned? These guys just cancel. Remember when a power and a base are the same, they cancel. Remember that's what logarithms are, is the opposites of powers. So X is 8, we're done. They just want to see if you know these cancel. Right? Remember, logs are the opposites of powers, huh? So if you have a power and a log and the bases are the same, 2 and 2, gone. Just cancel them out. It's just like an x squared and a root. They just cancel. It's just x, huh? They're opposites. They're like a poison and an antidote. They just eliminate each other. Right? Acid and a base. They just neutralize each other. That makes sense? They're testing if you know that a power and a log are opposites of each other. Let's try the next one. Log base 8 of 8 to the 4th. Log base 8 of 8 to the 4th. Answer is
4.
4, yeah, because these just cancel, huh? 4 and we're done. Is that making sense? So when the base and the power, when the two bases match, maybe I should say it that way. When the two bases match, it's a little more clear. Those are both bases. Just like these are both bases, huh? Right here, this and this. Yeah, that's probably a better way for me to say it. When the two bases match, they cancel. When the two bases match, they cancel. Is that good? Number 19, log base 11 of 11. Log base 11 of 11. What's up with that one? It is, yeah. Yeah, because again, they match, huh? The base and the base match. You can do it on your calculator, too. You could just go, it's just all numbers. So you can go, the top goes top, the bottom goes bottom. That's clearly 1, huh? It's the same thing over itself. There's an invisible 1 power here. That's why it's 1. 11 alone is 11 to the 1 power, huh? So these guys cancel, and the answer is just 1. Or you could just do top over bottom, 2 logs, log 11 over log 11. Is that confusing? I showed you 2 different ways. Maybe that's confusing. You could just cancel these guys out, so it's 1, or you could do it 2 logs. We learned both ways. The top goes top, the bottom goes bottom. It's 1. All right. In fact, I think I'll get a fresh screen here. Y equals log base 4 of x. Question 20, I mean. Y equals log base 4 of x. They want me to graph it, and they give me multiple choice answers. And so what I'm going to do is exactly what I did with the other graphs. So I'm just going to make a little XY chart. And I'm just going to go 0, 1, 2, just plug in some nice easy numbers. Hit the buttons on my calculator and put the dots on the graph and connect the dots. Ready? So I'm going to plug them in. So I'm going to start by plugging in 0. So first one is log base 4 of 0. Right? Good so far. I just plugged in 0 right there for x. Now how do you do that? Well, it's just numbers. So the top goes top, the bottom goes bottom, and your calculator is going to go air, huh? Get some kind of error, so I'm just going to write no. We'll see what that means on the graph in a minute. For now, it's just no. Can't do it. It's not 0, it's no. Huh? It's error or whatever. Next one. Log base 4 of 1. The top goes top, the bottom goes bottom, comes out 0, huh? Getting that okay? The next one, log base 4 of 2. The top goes top, the bottom goes bottom. Some crazy decimal. Oh, is it just a half? Oh, it's just half, huh? It's not really a crazy decimal. It's a half, all right? 0.5, is that right? So that's enough. Let's go to the graph. So on the graph, I don't know if I have room here. I'll just try to squeeze it in over here. So on the graph, over 0, no. I'm just going to write no in the center. Over 1, up 0. Over 2, up 0.5. So there's over 2, up 0.5. There's over 1, up 0. And then right in the middle is no. So somehow we have a graph that has those two dots. Now, what is a lot? There's a lot of things you could do with those two dots. Bless you. Now, what are we going to do? Well, let's go back and look at which graphs might have those two dots. Well, actually, there is only one. There's only one that has a dot here and a dot there. Can you see it? Yeah, it's A. Here's the deal. Logarithm graphs, what that no is where the graph takes a dive. It can't touch that wall. That's why it said air, and it goes like that. So that's how logarithm graphs, they're the opposite of exponential. Remember what exponential graphs did? Last section, they rocket up on one side, don't they? And flatten on the other. Well, logs are the opposites of powers, opposite of exponentials. So instead of rocketing on one side, they're going to take a dive on one side. So this one takes a dive. That's what the no is. That tells you right where it can't go. It takes a dive right at that no area. And it just goes up on the other side. So logarithm graphs always do that. They take a dive on one side. They rocket on the other. They just go up on the other. They take a dive on one side. So let's try. So that was A. Let's try 22. So try that one. What are you going to do? Make a table, right? Make a table. So make an XY table, put in 0, 1, 2. So log base 1/17 of 0 is log 0 over log 1/17, which is no. That's an error. Next we'll have log 1/17 of 1, which is log of 1 over log 1/17, which is 0. And the third one is log 1/17 of 2. Top goes top, bottom goes bottom. I have no idea. It's negative something, isn't it? What is it? Negative 0.25? Or 2.5?
It's 2.244.
Negative 2.244? Okay. So I'll just say 0.2. I mean, I can't do any more accurate than that on the graph. Negative 0.2. Is that good so far? You guys able to get those values? Can you put those dots on a graph now and remember that with the graph, takes a dive on one side? Because it's a logarithm graph. So let me bring that over. If I can erase this and put the graph here. Over 0, no. Over 1, over 2. Over 1, up 0. Over 2, down a little bit, huh? Over 2, down 0.2, over 1, up 0. So it's going down a little bit. So, yeah, this is a hard one. If it's going down this way, what must it be doing over here? It's got to be going up. Is that making sense? See, it's going up to the left and down to the right. Does everybody see how that's happening? Is that confusing? See how those two dots are going down to the right? So this one is actually kind of a reverse log is what it is. You know at the no wall, it's either going to go up or down forever. It's either going to go up or down forever at the place where you get the no. That one's going up. How do I know? Well, because it's going down to the right, so it must be up to the left, huh? See how it's going down to the right? Whereas the last one was going up to the right, wasn't it? See that? So which graph is that one? Which one looks like that? B.
But B looks like it's touching the 0.
Yeah, it's just really close. It's not really touching. It just gets super close. Okay, does that make sense on that graph? So I knew from this dot to that dot that it went down to the right. So therefore I knew it couldn't go like this, right? It's going down to the right. So this is down to the right on that. Is that making sense on that? Are we good?